Hello everyone, now we are going to do this question, which is when the light of frequency 2 mu naught, where mu naught is the threshold frequency is incident on a metal plate, the maximum velocity of electrons emitted is v1. When the frequency of the incident radiation is increased to 5 microvolt, the maximum velocity of electron emitted from the same plate is v2. So the ratio of V1 to V2 is options are 1 is to 2, 1 is to 4, 2 is to 1 and 4 is to 1. So now from the photoelectric equation we are going to use. So photoelectric equation is as you all know the H mu naught plus half m v square. Let me change my color. It's not visible as much. So H mu naught. So basically it's a photoelectric equation which we are going to use. So now as it was given that the frequency will be at 2 mu naught. So what we are going to use now, we are going to use now the 2h mu naught is equal to the same as the above plus same as, and it's half m v square, where v is the m1. Okay, now from the equation 1, which is this one, we can say that half mv square is equal to hv naught, and similarly for the half mv2 square is equal to 4 hv naught. Sorry, it's not the first equation. Just a second. This is the first equation from which we can say that h mu naught is equal to half m v1 square. Okay, through which we can say that. Now from similarly the second equation, for this we can say that the second equation will be uh, half mu naught square is equal to 4 h mu naught. Okay, so from v1 and it's not it's basically it's v2. Okay, for the second equation. So from first and second equation we can say that the common will be the v1 का square upon में v2 का square. Okay, is equal to 1 by 4. So it's 1 by 4, so answer is 1 by 2, because it is the square. When we find out for the v1 and v2, it will be 1 is to 2. So the correct answer is 1 is to 2. Okay, now see what's the answer. Yeah, the correct answer is 1 is to 2. Okay, so 1 is to 2 is the correct answer. Thank you everyone.